You know that feeling, right? The warmth of the sun on your skin on a nice day. It's something we've all felt. But have you ever really stopped to think about it? I mean, how does that warmth travel 93 million miles across the freezing, empty void of space to get to us?
Okay, so let's really get into it. To figure this out, we're going to have to take a little journey. And our first stop is the very heart of our solar system.
So, our journey starts right inside the sun. And you have to remember, the sun is basically just this giant, raging, fiery engine. We're going straight to its core because that's where this whole story really begins.
So, what's powering this engine? Well, it's a process called nuclear fusion. Deep down in the sun's core, the pressure is so intense and it's so incredibly hot, we're talking millions of degrees, that it literally forces tiny hydrogen atoms to smash into each other and fuse together. And that process unleashes an absolutely mind-boggling amount of energy. And here's the process, broken down. It's actually pretty simple at its core. You've got hydrogen atoms, the most common stuff in the universe, getting squeezed together. They merge, creating a totally new element, helium. And in that one moment of transformation, bam, a huge burst of energy gets released. Now, this energy doesn't just hang out in the sun's core. Nope, it immediately starts radiating outward in all directions, beginning this epic voyage across space in the form of electromagnetic waves. Think of it like the ripples from a pebble tossed in a pond, but, on a cosmic scale.
So, the energy's been created, but now we get to the really tricky part. How in the world does it make that 93 million mile trek all the way to Earth? I mean, space is a freezing, empty vacuum. How does warmth even survive that trip?
And this is what's so cool. See, here on Earth, we're used to heat moving in two main ways. There's conduction, like when the handle of a hot pan gets warm, and there's convection, like hot air rising. But both of those need stuff, particles, air, molecules, to transfer the heat. Space doesn't have that. It's empty. But the sun's energy travels by radiation, which travels in waves and doesn't need any medium at all. It can just go right through the nothingness. This special method of travel is called radiant energy transfer. And honestly, it's the whole reason we can feel the sun's warmth. These energy waves can journey across the absolute emptiness of space and arrive on the other side with all their power still packed inside. Pretty amazing. Okay, so the energy has made it. It's crossed the void, it's punched through our atmosphere. So what happens in that very last tiny fraction of a second when it finally reaches you? How does an invisible wave of energy turn into that feeling of warmth on your skin? And this is it. This is the aha moment. After traveling for over 8 minutes across 93 million miles, it all comes down to this one simple point of contact. This is where that incredible cosmic journey becomes a personal, physical feeling. Let's break down exactly what's happening. So get this, because this is the really wild part. The feeling of heat isn't actually something the sun sends to you. It's something that happens inside you. When that solar energy hits your skin, the molecules in your skin absorb it, and that jolt of energy makes them vibrate. They start to wiggle and dance around really, really fast. And it's that vibration, that microscopic dance party in your skin, that your brain interprets as warmth. But to really get the full picture, we have to look a little closer at what's actually in a ray of sunlight. Because it's not just one thing. It's a whole spectrum of different types of energy all bundled together. Yeah, sunlight is basically a cocktail of different rays. You've got visible light, which is, well, it's what lets you see everything. Then there are ultraviolet or UV rays. Those are the high energy ones you have to be careful with, the ones that cause sunburn. But the star of our show today, the thing primarily responsible for making your skin's molecules vibrate, is the infrared rays. That's the part you feel as heat. All right, let's put it all together now. We're going to summarize this entire incredible journey from the nuclear furnace at the heart of a star all the way down to a simple, pleasant feeling on your skin. And that's the whole story in a nutshell. You feel warm because a special kind of light, infrared radiation, travels through the vacuum of space, gets absorbed by your skin, and makes your molecules vibrate faster. It's an amazing, cosmic process that ends with a simple, personal feeling. So that leaves us with one last kind of mind-bending question to chew on. If all that powerful energy is traveling through space to get to us, why is space itself so incredibly cold? Now that you know how it all works, what do you think? It's a fun one to think about. Thanks for watching.